In this video, I'm going to go over some of the problems on the circles review for online quiz. So just a couple things to remember about a circle. Your equation is x minus h squared plus y minus k squared is equal to r squared, where the center is the point hk and r is the radius. So here on problems 1 and 2, you just identify the center and the radius and then graph it. Remember to graph it. Once you plot the center, you just, whatever the radius is, you go up the radius, down the radius, left and right. So here for problem number 4, I wanted to go over this one. The center, this is hk, so we have x minus 15 squared plus y minus 11 squared is equal to the square root of 3 squared. Except this isn't going to be written like this. The square root of 3 squared is just 3. So remember, just kind of, if an equation was given to you like this, you have to take the square root. And the radius doesn't always have to be a whole number, so keep that in mind. Okay. Problem number 6, it's a little bit trickier. They give us the center, and they give us a point on the circle. They don't give us the radius. So I want you to kind of think about what this graph looks like. It's just a very small sketch. So here's 11, here's 3, so here's my center. A point on my circle is at 13, negative 2. Well, it's not a very good point, but that's okay. So my circle goes, not a very good circle either, terrible, sorry. But essentially that's a point on the circle and that's my center. So this right here would be my radius. So we know the equation is x minus 11 squared plus y minus 3 squared, and then it's equal to whatever the radius is. So to find the radius, we'd have to do Pythagorean theorem here. Again, this is my r. To go from 11 to 13, this is 2. To go from 3 to negative 2, this is 5. And so 2 squared plus 5 squared is equal to r squared. Well, 4 plus 25 equals r squared, 29 equals r squared, and r equals the square root of 29. So when you go to write your equation, this would be equal to the square root of 29 squared, which we know that the square root of 29 squared is just 29. So HK was given to us pretty easy. They gave us a point on the circle, so I plotted it. And then I drew my circle. There's my radius. And then you have to find it by doing Pythagorean theorem. Problem number 7 is kind of similar in the fact that it's going to be helpful to draw a picture first. So, let's see. Here's 5. Here's 4. So these are endpoints of a diameter. So right there is one endpoint, and then negative 15, 4. That's the other endpoint of a diameter. So this line is the diameter. That lets you know that the center of the circle has to be in the middle. So you can ask yourself here, what's in the center of negative 15 to positive 5? we already know the y-coordinate's 4. Both of these had a y-coordinate of 4. So my center here is something 4. But halfway between negative 15 and 5 is going to be negative 5. The reason for that is from negative 15 to 5, those are 20 apart. Half of 20 would be 10, so that would be 10, and that would be 10. So this is negative 5, and then my radius here is 10. Because again, diameter was 20, the radius is half of that. So my equation is x plus 5 squared. It's plus 5 because my center is at negative 5. Remember, it's always the opposite. Plus y minus 4 squared equals 10 squared. Or, as the answer key has it, that's equal to 100. And if you just want to write 100, that's fine. You don't need to write it as 10 squared and kind of show that step, as long as you identify what the radius is somewhere. On problems 9 and 10, you just want to kind of find the center of the circle and the radius and then write your equation. Problems number 11 through 14, you want to write it in standard form, which is what we had up there, x minus h squared plus y minus k squared equals r squared. So to do this, when it's written in general form, and standard form is the same as graphing form, we have to complete this square. So I'm moving the 137 over, and I'm also going to kind of switch these two terms right here. So my x's are together, my y's are together. X squared plus 22x plus y squared minus 16y equals negative 137. So here you want to complete the square for the x's and do it again for your y's. So my x's, I have x squared, cut this in half. Half of 22 is 11. So 11x on both of those. That lets us know right here, this should be 121. So we need to add a 121 on both sides of my equation. And then make another square for my y's. Y squared, half of negative 16y is going to be negative 8y. So for this one, we're missing a 64. So I need to add 64 to both sides of my equation. The reason we added 121 was to make this a square so that we can write it as x plus 11 squared. And then here we added 64 so we could write this as y minus 8 squared is equal to 48. I know this problem doesn't ask for it, but it's a good habit to kind of think and identify the center and radius. It doesn't take long. So remember, your center is HK. Since this is x plus 11, your center is negative 11, positive 8, and your radius is the square root of 48. Yes, we could simplify this. We know how to simplify square roots. I'm not going to worry about that right now. But it just gives you an idea of what this means and what the graph would look like. That would be your center, and your radius would be about 7. Not quite, but about 7. Let's see. A couple things to remember here. Remember, the arc measure is equal to the central angle. If it goes through the center like this, that's going to be a diameter, which means it cuts the circle in half. I want to go down to problem 22. So this problem, there's kind of a lot going on. We're trying to find angle BZA. So really, this is what we're finding. This is kind of our question mark. In order to find that question mark, we would need this arc right here, which is this arc here, ZA. If we could find arc ZA, then we could cut it in half to find that. Well, hopefully you notice that this goes through the center. Since this goes through the center here, that tells you it's a diameter. If it's a diameter, it cuts the circle in half, which means the measure of this arc would be 180. So if I just want to find ZA, you would do 180 minus 64. So ZA here, that arc, would be 116 degrees. Again, this goes through the center, so it makes it a semicircle. So this arc measures 180. We already had 64, so this leftover part was 116 here, which here, so if I want to find this inscribed angle, I cut it in half, and half of 116 is 58. Remember, inscribed angles are half of the arc measure. On problem 21, again, kind of busy, lots of lines going on. Look at just what you need. Look at what you have. Look at what you're trying to find. 23 is similar. This is a semicircle, which lets you know you have half of a circle here, 180, and so you can find this arc measure, helps you find this one. On this guy here, 24, you should be able to find WX, because you should know that all the way around the circle adds up to 360. And so once you find WX, again, just pretend arc WX, pretend like line WX isn't there. And that's what you're looking for. So if you know WX, you can find that inscribed angle. Alright, but problem number 26, we have two chords that are intersecting inside of a circle. Remember, we can make these into then triangles, which those vertical angles are the same, and then these angles down here are the same. So by setting up these similar triangles, we can set up a proportion. So my proportion here would be 2x plus 4 over 3x plus 1 is equal to 7 over 8. No, that's not the only way to do it. And I also could have drawn my triangles going the other way. It doesn't matter. If you set it up correctly, when you cross multiply, you should get the same thing. So you get 16x plus 32 equals 21x plus 7. Subtract 16x on both sides. 32 equals 5x plus 7. Subtract 7. 25 equals 5x. Divide by 5. And we get x equals 5.